Well, it's 10 o'clock and we're going to start another rendition of the Long Coffee Break. My name is James Murphy. I'm a sales engineer here at Long. We're lucky enough today to be joined by Einar Frogelbaum from Carson Solutions. We're going to talk about displacement ventilation and improving indoor air quality, specifically with displacement ventilation utilizing chill beams. Einar?
Excellent. Thanks, James. And as James mentioned, yes, we will be talking about displacement ventilation and specifically displacement induction ventilation. They are distinct technologies, and it's a technology that's been applied for nearly 2 decades, predominantly in the classroom environment for K through 12 in higher education. And in today's times, it just makes sense for the ability to deliver a better indoor quality and remove contaminants proactively. So as we step through, there's a couple of key items that I want the group to take away. Certainly, I want to understand the difference between displacement ventilation and a mixed air system. Understanding that all displacement ventilation is not created equal. And we'll talk about displacement induction versus traditional displacement a little bit. And then understanding the importance of third-party testing and validation to prove better indoor air quality and contaminant removal. And then beyond IAQ, this system will ultimately deliver better system efficiency, thermal comfort, acoustics, and decreased maintenance. We talk about mixed air versus displacement. Mixed air could be unit vent, fan coil, overhead diffuser, and all those systems do a very good job of mixing the environment. So not just adding more air does the right solution, but understanding how air moves through the room is important as well. So if you look at the smoke video, you can see a mixed air system that has high velocity air and churning the room, and our natural contaminants, when we breathe and exhale, they want to go up because they're warmer, and you can see this video wants to do a good job of pushing those contaminants back into where the people are at. Compare that with displacement, which doesn't have a fan-powered device. It uses the buoyancy effect of the heat sources in the room, and it effectively purges the contaminants and reduces the fan energy for the system. So displacement 101, typically we've got the diffuser in the zone, and as that supply air comes out of the diffuser, 63, 65 degrees, it slowly drops to the floor and then migrates across the room until it comes in contact with the occupant, which adds temperature, increases buoyancy, and will create this thermal plume or convection current that effectively lifts that fresh air directly to the occupant. But more importantly, that convection current travels upward and lifts the expelled contaminants up and away from the breathing zone. I'm not saying that there's no cross-contamination from person to person, but it's a heck of a lot less than a system that is trying to force air back down into where the people are. I think this comment from the EPA is very important and interesting to the fact that they went to the depths of talking about the type of air distribution. The highlighted yellow area says designers should investigate a method called displacement because it uses natural convection to eliminate fan power consumption, as well as lifting contaminants up and away from the breathing zone. Pretty powerful comment from the likes of the EPA to talk about something in so much of the weeds like types of air distribution. So key point, how does the system all kind of come together? It is typically comprised of a dedicated outside air unit that feeds a known amount of outside air at a right condition to the space, but it delivers that air directly to this diffuser. And so the only difference between this system and maybe a fan coil, DOAS-based system, water source heat pump, VRF, is how that air moves through the room, takes contaminants, and then is ultimately exhausted is the difference. So it's often a DOAS, a chiller, a boiler, and a terminal device. What's also critical is that with the DOAS structure, there is no room-to-room cross-contamination like you would see in an air handler VAV arrangement. Here's just a different schematic of how those components come together. You can see the DOAS unit feeding the 100% outside air to the terminal devices in the classroom. And very typically, you're going to have a boiler that's producing hot water for heating in the zone, as well as preheating the outside air at the DOAS unit. And very often there's a chiller that's producing chilled water for sensible cooling or dehumidification at the DOAS. I was working with James in a recent project, and he actually upgraded to a heat recovery chiller, which increased the system efficiency as well. How does the QLCI work? It is an induction unit. It is a chilled beam. So the driving force of that is a 100% outside airstream that is fed to the DOAS unit, fed to the QLCI. And as that air comes into the plenum, this plenum runs the full length of the cabinet. And at the bottom of this plenum is a series of nozzles. And as that air goes out the nozzles, it creates a Venturi effect, which pulls in 2 parts room air across this hydronic coil. That hydronic coil heats or cools that room air, mixes with the 100% outside air portion, and now we get 3 parts of supply air out to the space at a low velocity, moderate temperature, with no moving pieces and parts within the zone. Each QLCI is 13 inches in depth, 30 inches in height, and varies in length from 4 feet on up to 8 feet. And usually there's 2, 3, or 4 of these devices in the classroom to produce the heating and cooling and ventilation air. Here's that same smoke video lab, and you can see the outside or the fresh air coming into the room, low to the floor, very quiet, very low velocity. And now this middle mannequin is heated to show that process of displacement of lifting fresh air to the breathing zone, and more importantly, lifting those contaminants up and away from the other occupants, mannequins in this case. Operationally and schematically, when we go into cooling for a typical classroom, we're only bringing in the ventilation amount of CFM to these spaces. So dehumidified outside air comes into the plenum. We induce 2 parts room air that go across that hydronic coil. That hydronic coil is being activated with elevated chilled water temperature, 57, 58. And now we have those air streams mix and produce the supply air that come out in the space, come in contact with the occupant, and you get that displacement ventilation effect, lifting those contaminants. So over here on the left is the induction process, and over here is the displacement, and those 2 technologies combine to produce displacement induction ventilation. Heating. I'm in Minneapolis, and over nearly 2 decades, in nearly 300 school buildings alone, we've been successfully applying this technology in a very extreme environment. So how do you heat with displacement? The key point is not to deliver too hot of air. And we want low-grade heat going out into the space and then coming in contact. We can deliver low-grade heat because the occupants within the space offset that sensible load by about 50%. So we don't need 85, 90 degree air. And that's so critical to delivering these better indoor air quality levels year round. So when we go in the smoke video, takes a little while, but I want you to pay attention to the horizontal travel of the smoke. And it's not until they come in contact with these heat probes that the air goes up. And again, taking those contaminants up and away from the occupants to deliver year-round better IAQ. The proven aspect. So we delivered equipment to Purdue. They put our equipment through very stringent testing, and they mocked it up in their IAQ lab, and they put our equipment through all modes of cooling as well as heating. And what they proved is that we delivered a stratified room condition in both heating and cooling. And what's the takeaway is that, excuse me, this yellow highlighted area, it says airborne, this is a statement from ASHRAE about a year ago, said the airborne transmission of COVID-19 is significant. And I don't know if it's COVID today or the flu's not going away, the cold's not going away, so doing a better job of ventilating is key. And if you take the measure of ventilation effectiveness, which is really a contaminant removal effectiveness, and the findings that Purdue proved that we outperformed traditional displacement in cooling, and we delivered a stratified condition in heating, so that we're proving that we're delivering a better indoor air quality year round. It's not just us. If you want to click on ASHRAE's virtual conference from last year, you'll see 2 industry experts talking about what's the difference between mixed air and displacement ventilation, and what does better for contaminant removal. Here's a summary of Dr. Chen, who specifically compared our equipment to a mixed air system. And he said the ventilation effectiveness was proven to be better than traditional displacement. We created a stratified condition in heating mode as well. And the findings here can be extrapolated to its effectiveness in removing particles, which is the aerosolized concern related to contaminant spreading. Beyond the benefits of indoor air quality of the system, the benefits are energy efficiency, thermal comfort, noise, maintenance, and construction. So from an energy efficiency standpoint, the best controlled experiment I can reference is two identical buildings. The first building was built and applied displacement induction chilled beams in the classrooms. The second one applied an overhead chill beam, which went to a mixed air system. And when they compared the utility consumptions between the two buildings, the first building with displacement was 20% more efficient than the identical square footage building with traditional overhead mixed air systems. Additionally, we just came out of an energy modeling study in a full year of simulation with a local engineering firm and their energy modeling team. They modeled this single-story elementary school. They modeled the entire HVAC equipment for the entire building. And their findings were, if they just changed the classroom wings from air handler VAV to DOAS QLCI, they saved for the entire building in Minneapolis, Grand Junction, DC, Columbus, and Seattle, they saved that entire building about $20,000 to $25,000 per year just by affecting half the building by making it more efficient with this dedicated outside air and displacement system. Thermal comfort, I call it maximizing floor space. Because of this full wall delivery of air at a much more moderate temperature at a low velocity, we create a much more comfortable environment such that these school districts can maximize floor space. And if these students felt the draft on their ankle, or Jimmy sitting next to the diffuser felt warmer or cooler than Jenny on the other side, they'd complain and they wouldn't leave these rooms in this arrangement that you see here. Acoustics. Acoustics cannot be overstated. Because I don't have any moving pieces and parts, don't have any fans, don't have any motors, we can create a very quiet environment such that the students are much more engaged and the teachers are much more effective teachers because they're not dealing with distracted learners. Our measurements in our rooms are roughly about 35 dBA compared to a room with a unit vent. The background noise will be about 55 dBA. Again, don't have any moving pieces and parts to interrupt learning. Don't have any moving pieces and parts to maintain. There aren't any filters that need to be addressed within the classroom. All the maintenance aspects are addressed outside of the classroom, so it's very unintrusive to the classroom environment, and it's very efficient and an operating savings for the staff. Here's a nice progression from design to installation. The engineer laid out this elevation view with two QLCIs directly underneath a window with integrated bookshelves. This 3D rendering was taken by the architect and presented to the school district and said, school district, you have a whole lot of cinder block wall, not a lot of natural lighting. We're going to give you a lot of natural lighting and an integral piece, single piece of HVAC equipment that delivers outside air, heating, cooling, all as an integrated piece of furniture that's usable for the students and the staff. Here's ultimately what we delivered, which was 3 QLCIs delivering the fresh air in the left-hand corner and the right-hand corner to the diffuser. But what's noted here is because we're only delivering 300 to 400 CFM of ventilation air to the space, we can deliver a 12-inch round, which very easily meets the common hurdle of, I don't have any plenum space. This plenum space between the drop ceiling and the roof line was about 16 to 18 inches. Very clean installation, very little coordination of fire and suppression, no electrical that you need to bring in. So it's not just displacement ventilation, it is the system. By applying a dedicated outside air unit, we deliver a known amount of outside air. We apply displacement for contaminant removal and better indoor air quality, better thermal comfort. better maintenance, better system efficiencies. So we check all the boxes that are so important to these school districts. And if you do have a school that does have aging unit vents, this is absolutely a home run because we can take advantage of the utilities and the hot water, chill water that's already in place, give them that same functionality and look with the bookshelves. We can eliminate noise and concerns, thermal comfort. We don't have to bring electrical into the room, and we deliver a known amount of outside air to these spaces, which is critical in today's environment. What I like about displacement is that it delivers better indoor quality and better ventilation approaches and practices when it's most critical, when the students are there, and we're lifting those contaminants when the people are present. So if we can deliver a better indoor air quality, a healthier, safer environment is afforded to these students, to the staff, and so the students and the parents can feel like they're safe and just like they were studying at home. Lots of information that we covered here today. Please, if you do have any follow-up questions, please connect with your local Long salesperson. And with that, I will turn it over to James to kind of wrap it up.
Thanks, Einar. Yes, please contact any of your sales engineers here if you have any questions. Please join us next week when Devin Gash will be giving a presentation on plastic fans. Thank you so much, and stay safe.